Hello and welcome, everyone. We're really glad to have you here today for the next installation of our series Day One and Beyond, which is related to topics and activities building out on the cloud. Many of you may have joined us for previous ones, so welcome back. If you're new to the series, just a quick heads up that we are hosted on Cloud Customer Connect, which is Oracle's community forum for end users. And if you haven't explored that forum yet, I'll be sharing some resources for you where you can set up a free account and look for discussions and post questions and watch for upcoming events like this one on all kinds of topics. My name is Kenna Ketrick. I'm a program manager with the OCI go-to-market team, and I'm joined by Kumar and Brandon Alarie, both cloud engineers here at Oracle. And today we also have a special guest, Raffi Shahbazian, principal cloud architect, for this focus on networking quick start on OCI. Uma, it is all yours. Go ahead and take it away.
Well, thank you so much, Kenna. So as we are, finishing up this poll that she just put up, we'll just go ahead and introduce ourselves again. So hi, everybody. My name is Kumar. I'm a cloud engineer on the customer enablement team, and I have been running this series with my colleague, Brandon, for about, I think this is our 5th session. So our last one will be in 2 weeks. But today we'll be focusing on networking. So I'll let, Brandon introduce himself as well as our special guest, Raffi.
Hi, everyone. My name is Brandon Alarie. I'm a cloud engineer here on the Oracle Customer Enablement team, and it's good to be back.
Hi, everybody. Raffi Shahbazian. I'm a principal cloud network architect here at OCI. Really looking forward to providing, a high-level information on what we could do over here. So hoping, to make this a fun event for us. Thank you.
Thank you, guys. So before we get started, I just wanted to go through the agenda again. So today, like we mentioned, this will kind of be our deeper dive into networking. So if you were here for the earlier sessions in our cloud technical quick start, Brandon and I went through networking, but pretty briefly. So now we'll be talking about a variety of different things, going over virtual cloud networks and the different components involved with it, as well as taking a look at security aspects, peering, connecting to the internet, connecting out of your VCN, as well as things like load balancers and connecting to on-premise like Fast Connect. So those different types of solutions. And you've definitely seen this slide before. If you're familiar with this series, this is just an overview slide of our different cloud services. So today we'll be focusing on the bottom under core infrastructure, mainly on networking. So like I mentioned before, load balancing service, the different gateways, Fast Connect, VCNs, and things like that. So this is just our general overview slide of some different important components in networking. So VCNs, like we mentioned, right underneath that is the service gateway. So that's a way to connect privately to our different Oracle Cloud Infrastructure, PaaS, and IaaS services. We'll also be talking about all the different types of gateway. So going through what a DRG is, internet gateway, things like that. And then in the next kind of column, talking about Fast Connect as a way of, utilizing the hybrid environment, connecting to your on-premise, as well as utilizing OCI. And then lastly, we'll definitely be touching on our load balancing service, as well as our DNS as additionally.
Yep. So our first topic here is on virtual cloud networks. So a VCN or virtual cloud network is a software-defined network that you set up within OCI within a particular region. And then you can also subdivide your VCN by using subnets. And we have private and public subnets, which we'll talk about in the next few slides. A virtual cloud network is going to reside within a single region, but can span across multiple availability domains. So if you remember, we have our region, and then within our region, we have multiple data centers. Typically, there'll be about 3 data centers or availability domains within each region. And it's important to note that each VCN has various components that directly affect the behavior of the network, such as, the different gateways that are attached to it. And when you create one of these components, you establish a relationship between that component and the VCN itself. This means that you must be allowed within an identity and access management policy to both create that component and manage the VCN itself. However, the ability to update that component, for example, change the route rules, security lists, or, interact with some of the different gateways does not require permission to manage the VCN itself, even though changing that component can directly affect the behavior of the network. So this discrepancy is designed to give you flexibility in granting least privilege to users and not require you to grant excessive access to the virtual cloud network, just so the user can manage other components. So it's important to be aware that by giving someone the ability to update a particular type of component that's connected to your VCN, whether that be a route table or a gateway, you're implicitly trusting them with controlling the network's behavior.
Mm-hmm. And so now we can talk a little bit about, our VCN address space. So Raffi, I was wondering if maybe you can jump in here and provide, kind of some more insight on what kind of ranges does OCI cover, and kind of how does the address space work when you're creating a VCN? Like, what should customers basically keep in mind when doing so?
Yeah, absolutely. Thank you, Uma. So, thanks for that explanation, Brandon, on VCN and the basic constructs of it. Essentially, when it comes to IP addressing, what we want to do is properly manage the IP address scheme. So what we do is we support as big as /16s for a VCN CIDR range and as small as a /30, for example, within OCI. So /16, gives us a large amount of hosts, which can be further, segmented using subnets, for example. /30 essentially gives us a very finite amount of hosts. So we do reserve the first and the last IP of these ranges. So that's just something to keep in mind. Every resource that's connected to the VCN, whether it's a compute node, a database, or any additional resource, is essentially going to consume these IP addresses. So we do need to keep that in mind when we're designing the VCN CIDR ranges. CIDR ranges can be further segmented using subnets. So for example, if we did have a /16, we could divide that up into several /24s. And essentially, just like we mentioned, the compute instances or databases or any other OCI resource can be deployed within these subnets. So that's very high level overview. Subnets can essentially be private or public with regards to that. So what we mean by that is public subnets could have access to the internet and could have public IP addresses assigned to the compute nodes, whereas private subnets essentially are just private IP CIDRs. So we support the RFC 1918 CIDR ranges. We also support the 100.64 range. So this is pretty much covers the VCN address space and how to use it. Now, let's assume we do use our VCN CIDR completely. What we could do is we could also adjust these CIDR ranges on the fly. And we can also add secondary CIDRs to these ranges if we wanted to deploy systems, compute instances in different CIDRs than the ones we originally deployed the VCN with.
Mm-hmm. Yeah. So, and then I think something else too to keep in note is we have to make sure that these CIDR ranges aren't overlapping as well. So like if you have multiple VCNs in your tenancy and same with subnets in that VCN, can you explain really quickly, like what are kind of the range? So I know a VCN can span multiple regions. Can subnets do that too? Or is it still AD specific? I think in this quick diagram that we have up here, there's just one VCN for one region, and then we have two subnets in one specific AD, but I'm not sure exactly do you remember what that range is? If you can
I think that's a really good question. So we support subnets that are regional or AD specific, and so what this means is a subnet can span across the regions that we have multiple availability domains. Essentially, this cannot be done in other cloud providers, for example. So, or we could keep it AD specific as well. So if we did have multiple ADs and we wanted to keep them unique, each AD unique to each subnet, then we can certainly do that as well.
Mm-hmm. Okay, got it. Thanks for that.
All right, and next we can talk about the route table. So your virtual cloud network is going to use route tables to send traffic out of the VCN. for example, to the internet, to your on-premise network, or to another peered virtual cloud network. And these route tables have rules that look and act like traditional network route rules that you may already be familiar with. Each rule specifies a destination CIDR block and the target, which is the next hop for any traffic that matches that CIDR. The primary routing scenario is for sending a subnet's traffic to destinations outside the VCN. A subnet has a single route table of your choice associated with it, and all of the VNICs or virtual network interface cards in that subnet are going to be subject to the rules of that route table. And some other points here. Traffic within the VCN subnets is automatically handled by the VCN local routing, so no route rules are going to be required to enable that traffic to flow. And then if there are no route rules that match the network traffic you intend to route outside of the VCN, the traffic is going to be dropped. So like I said, each subnet within a VCN is going to use a single route table. And when you create the subnet, you can specify which one to use, but you can also change this later, if you need to.
Yeah. Yeah. So like you mentioned before, when it's locally within the VCN, that's automatically handled. But this route tables are mainly for how you're trying to route traffic outside of your VCN, right? So we can kind of see that in this little screenshot that we have different target types. So routing using a NAT gateway or service gateway. And I think, the little descriptions is giving us like, what is that actually doing? We're routing out to the internet, or we're accessing object storage or something. So I think that's a great transition actually into talking about, what our gateways are and those different types, like those different types of communications from your VCN or from your private network. So Raffi, can we talk a little bit about, what an internet gateway is, what a NAT gateway is, like how they differ, what they would be used for, when should you use which one, stuff like that?
Yeah, absolutely, Uma. Oh, thank you. So ultimately, we do have an internet gateway and a NAT gateway. And the primary difference between the two is if we were to leverage a public subnet where we are assigning public IP addresses to the resources within the subnet, in order to route back and forth from the internet, we're going to leverage the internet gateway. Internet gateway will give the ability for bidirectional connectivity. So what I mean by that is we could egress out of the cloud infrastructure towards the internet. And likewise, we can actually make connections back onto the public IP of a given instance that resides in the public subnet to manage the instance, whether it's SSH, right, web, so on and so forth. We could have applications hosted and things like that. NAT gateways, on the other hand, it only enables outbound connections to the internet, but we block the inbound connections. And right, this is good for instances that are residing in private subnets that need to, say, perform patches or updates or just need general internet connectivity outbound. So essentially, those are the primary differences between the internet gateway and the NAT gateway. And they're both essentially service offerings towards the internet, and the internet gateway is a service offering back towards the cloud from the internet.
Yeah, definitely. And so now we can kind of talk a little bit about how we would do it from on-premise, which is our DRG, correct?
Correct. DRG, Dynamic Routing Gateway. And this is actually a really powerful construct we have here in OCI. It's essentially a virtual router. And this virtual router is going to manage our connectivity to and from on-prem, whether we're using Fast Connect, which is a private dedicated link between, say, OCI and the customer data center natively through cross connects, or between OCI and the customer data center through third-party providers or partners. Essentially, it is the way to connect into OCI through a dedicated, private, reliable link. We also offer connectivity into OCI using IPsec VPN, right? Standard technology that's widely available. So IPsec VPN, of course, is a very quick way to connect to OCI through private, secure channels, leveraging the internet. However, it's a best effort service when compared to the Fast Connect service. Dynamic Routing Gateway, I just want to note to the audience, we just recently released a technical overview and a detailed workshop where we deploy design patterns and how we could leverage the DRG using all the various components of the DRG. We will be sharing this YouTube link for the video as well. So it's about a 43-minute video. I encourage everybody to watch it.
Yeah, thank you. So Brandon, do you think you can take us through a little bit about, how we communicate? We just talked about communication to our on-premise. What about the different like public OCI services? So if you're using, an autonomous database instance or integration cloud, like those kinds of PaaS services, just an overview of, what the service gateway is and what it can do.
Yep. So we have our service gateway, and this lets resources within our virtual cloud network access public OCI services such as object storage, but without using the internet or NAT gateway. So your traffic's going to stay, on the Oracle backbone. And the main use case here is for, database backups. This is a great example. When you send your database backups within your cloud or within your virtual cloud network to object storage, you can leverage the service gateway.
Yeah, definitely. And then, we mentioned our DRG in terms of routing traffic to, your on-premise applications and resources, but then you can also use it for something called peering as well. So can we talk a little bit about the, different types of peering and why we would use them as well?
Yeah, so we have local peering and we have remote peering. So local peering is going to be connecting two virtual cloud networks within the same region so that their resources can communicate using private IP addresses. And then for that, you're going to leverage our local peering gateway. And then if you wanted to peer to different virtual cloud networks within different regions, you would use DRGs or dynamic routing gateways. And this is just the process of connecting two virtual cloud networks in different regions so that their resources can communicate using private IP addresses. So the main difference here is, with remote peering, you're leveraging that DRG, and then with local peering, you can use our local peering gateway.
Got it. And also, I think, I'm not sure if Raffi mentioned this as well, but I believe a DRG it has a one-to-one relationship as well with a VCN. So let's say, you have one VCN. Raffi, are you able to use the same DRG to peer to, let's say, a second VCN in a different region, and then also to your on-premise?
Yes, so it was about a year ago, we introduced some really cool DRG enhancements, Uma. Essentially, now we support up to 300 VCN attachments per DRG, and we can do some pretty fancy routing with that as well. We can also enable different regions VCNs to connect to an alternate regions VCN's DRG, for example. So we do support VCN connectivity or attachments to DRGs at a very large scale at this point.
Mm-hmm. Okay, great. And so now we can talk, a little bit about the VCN security. So we'll talk kind of on what a security list and a network security group is. So we have these two different rules. So I think what would be great to start with is kind of talking about, what stateful versus stateless is and kind of when you would use them as well. Raffi, do you think you could explain a little bit about that?
Yes. So by default, subnets are going to be associated with security lists. And essentially, security lists are stateful security lists. So what I mean by stateful is what we allow in, we must explicitly allow out as well. So we have ingress and egress components to the VCN security lists. Essentially, they're virtual firewalls that are attached to a subnet. So this is subnet specific. So any resource that's deployed within the subnet will by default be subject to the security list. Now, security groups, on the other hand, apply to VNICs of resources that are deployed within OCI. And essentially, this is going to be something that's used for, say, a group of nodes or a group of VNICs that have the same type of security requirements, and they can be grouped together into network security groups. Now, it's important to understand that network security groups and security lists do work in conjunction, and essentially, it's the union of the two. So if something is allowed within the security list and not allowed in the security group, the less permissive will win. By that, what I mean is it will be by default allowed. if the security list permits it and the NSG does not permit it, for example. So key takeaways here: NSGs apply to VNICs, whereas security lists apply to subnets. Both of them, however, are stateful.
Mm-hmm. Yeah, so I think that's kind of what our next slide is kind of going through some of those differences that you just talked about. So you can kind of see, like, on the left-hand side, we're looking at the subnets, and then the right, it's specifically looking at, your instances. And so that seems to be the main takeaway, is that the rule should be reflected both in the security list and the NSG for them to be true. Is that correct?
Yeah, so it can be in either or, Uma. So
okay. So either or, not both. Okay. Great. And then we can take a look at questions too. I think there were a few that we haven't answered. So maybe we can answer a couple of them live before we move on to the next topic. So we had one about the hub and spoke topology, and if there's any reasons to choose a VCN based topology versus a DRG based topology. So Raffi, do you know if there's any kind of specific reasons why you would choose one or the other, or is it just kind of dependent on what your requirements are?
It really does depend on your requirements, and that's actually a really good question. Thank you for asking that. So just to briefly go into this, there are a couple of ways we can ultimately deploy and achieve a hub and spoke technology. I would say initially when we deployed OCI, what we did was we had hub and spoke technologies by way of LPG, or local peering gateways. And on day one, we were able to transit right through the hub VCN by way of spoke VCN. So it was a transitive routing was supported with this hub and spoke topology using the local peering gateways. Now, DRG, on the other hand, is right to be able to achieve the hub and spoke technology, especially with the newer enhanced features we released about a year ago, is far more scalable than, say, LPG hub and spoke topology. And what I mean by that is we could granularly segment traffic using the DRG based on route distribution lists, based on DRG route tables, so on and so forth. And we could scale this up to potentially 300 VCNs, whereas in a local peering gateway hub and spoke topology, it's far less limited. We have a service limit of 10 LPG attachments today. So, and we would have to essentially create an LPG mesh if we wanted to, say, have VCN peerings going back and forth that didn't necessarily have to cross the hub and spoke technology. DRG is a lot more easier, I think, in my opinion, to scale, grow, maintain, and from an operations perspective as well. So there are a lot of benefits, Tatiana, and hopefully the DRG workshop that we're going to share, again, it's just a quick 43-minute video. You'll get to see some of the examples on how we're leveraging a hub and spoke technology within that video.
Mm-hmm. Got it. And then we had another one talking about, when you define the VCN, you're choosing your public and private subnets, but when you see the IP allocated in a subnet, it's only really showing like your private CIDR block. So someone is asking where the public IP is in this case.
Yeah, absolutely. So when we deploy, let's say, a computer instance in a public subnet, we have the ability to, during the deployment, actually say, do we want to reserve a public or an elastic IP for this or not? Let's assume we say yes. It would need to be deployed in a public subnet. And once the compute instance is deployed, we should see not only the private IP, but just a few lines right above that, we're going to see the publicly routable IP as well. If, let's say, for example, we had deployed a computer instance in the public subnet and had not selected the reserve public IP address, well, what we could do is just reserve a public IP address within the OCI console and associate it with the VNIC.
Mm-hmm. Yeah, that definitely makes sense. And then one more, I think, before we can move on is why does Oracle recommend using different compartments for dev, test, and prob using multiple subnets in a single VCN? So I can kind of try and take a stab at that one. For me, I feel like that's more of organizing your resources, right, logically, whereas, your VCN is like the actual virtual way that you're going to be routing traffic. So I think it's not saying that you can't do that. I think just from a governance perspective, being able to look at all the different resources in one place for a compartment would make more sense to have that versus a subnet and VCN of organizing. But Raffi, what would your thoughts on this be?
I think you're spot on, Uma. It's essentially for governance, managing it. You might have more lenient policies in your dev and test environments where prod could be heavily restricted. So I think it's a much more safer way to manage your resources as well. So no, I think you nailed it, Uma. Thank you.
Mm-hmm. Got it. And then one more just popped up saying, so we'll need to create an internet gateway and then set that in the route table at the VCN level, right? So can that be done at the subnet or VCN level, Raffi?
So we'd have to create the internet gateway within the VCN. However, the internet gateway, in order to leverage it, you'd have to modify the route tables. So for example, let's say I have a subnet that's associated to a route table. Within that route table, I would have to add a route rule saying, quad zeros, for example, and my next hop would be the internet gateway for that VCN.
Okay, got it. Thank you. So now we can move on a little bit and we can talk a little bit about load balancers now. So I'll let Raffi kind of walk us through this kind of service and talk about it a little bit more.
Yeah, thanks, Uma. So load balancers, I think is, very fun topic here. So essentially just a very high level overview. Load balancer, right, will sit between the client and the backend servers that actually perform the tasks. So what we do is we do service discovery, which backends are available, how the LB should talk to them. We perform health checks against the backends just to make sure that they're healthy so they can stay in rotation within the load balancing pool. And of course, we have a few different algorithms where we support the load balancing, whether it's by weight or round robin, for example. The options are available to us. Now, by default, load balancers are fault tolerant in HA. So by using a combination of health checks and LB algorithms, load balancing algorithms, we can effectively route around a bad or overloaded backend. Load balancers by nature are scalable. So we maximize the throughput, minimize the response times, and we avoid overloads to any single resource. And name abstraction, of course, name resolution can be delegated to the load balancer. So the backends don't necessarily need public IP addresses. We could essentially connect to what we call the listener, which is what the client would connect to using name resolution, DNS. Excellent. Thank you, Uma, for that. So when we deploy a load balancer with an OCI, essentially it is highly available and fault tolerant. Let's say, for example, in this case, we're saying the listener has a public IP address, and that public IP address essentially will connect to the active load balancer from, say, the consumer's perspective. The end user is coming in through the internet, in this case, will connect to it, and it'll connect to the active load balancer's public IP address, which is the listener side. Now, if anything happens to that active load balancer, of course, we fell over to the standby backup load balancer. So we are redundant and fault tolerant, highly available with that regard. Now, as far as the backend sets are concerned, which is the sets of nodes south of the listener, these are essentially registered with the load balancer, and they will be in rotation as long as they are passing the load balancer health checks. So if one of these 4 nodes at the very bottom of the screen was failing a health check, it would no longer be participating in the load balancing pool for this given service.
Yep. And we also have DNS service. So this is a highly scalable global Anycast domain name system network that assures high site availability and low latency. And this kind of shows some of the different features of our DNS zone management. So within DNS zone management, you're able to create and manage zones and records. You can import and upload zone files if you already have those. And you can also interact with our DNS zone management with APIs and SDKs. And then within the service, we also have many different traffic management and steering policies. So The first one here we have is our load balancer policy, and this is round robin load balancing that can be used to distribute traffic among multiple servers to optimize performance. We also have our failover, so it's easy to set up a simple active-active failover between two public assets. OCI will monitor the primary endpoint and reroute all traffic to a failover location if the primary endpoint is unresponsive. We also have geolocation steering. So based upon the source of the request, our geolocation steering can dynamically route requests to appropriate response pools based upon your end user's physical location. And then we have ASN steering and IP prefix steering as well. All right, and then for connectivity options, so we do have our public internet, we have our VPN connect or IPsec VPN, and then we also have our fast connect. So for the public internet, we are able to use reserved IPs and the internet data out pricing. So our first 10 terabytes are free per month. And then we do have like very low costs, after if you were to reach that 10 terabyte threshold. With our VPN Connect, so we do have two options here. We have our OCI managed VPN service, which is free. And then we do have a software VPN, which would run within your tenancy on an OCI compute node. And we also offer Fast Connect. And this is for private dedicated connection to your virtual cloud network with consistent, it's going to provide you with a consistent network experience. And there's different port speeds available to you. So you could have 1 gigabit per second or 10 gigabytes per second. And then there's SLAs or service level agreements to, back our Fast Connect.
And Brandon, I'm sorry if I may, I just want to mention, we also started offering 100 gigabits connections for Fast Connect as well recently. So.
Okay, awesome.
Thank you.
Yep, and then we have this visual here. So this kind of shows you the difference between our public peering and private peering. So with our, Fast Connect private peering, you're able to connect from your on-premise data center to your virtual cloud network. And then with our public peering, you're able to, connect from your on-premise data center to our public OCI services, such as object storage. Raffi, did you have anything, else you wanted to add in here about Fast Connect?
Yeah, no, I think this is pretty good. So private peering essentially is going to give us the ability to connect to our resources within the VCNs, and public peering will give us access to object storage or services within the OSN, the Oracle Services Network. There are ways to leverage access to the OSN using private peering as well with advanced routing features, but this pretty much sums it up. Thank you, Brandon.
Mm-hmm. And then maybe we can have a quick look at the Q&A before we go into the console, and Raffi can kind of take us through a quick demo. So one question was, does the load balancing as a service support sticky connections?
Yes, so we support session persistence by way of cookies. The cookies can be implemented on the load balancer itself, or they could be application cookies as well, but we do support sticky persistent connections.
Yeah, and then we have another question on spell out clearly the benefits, maybe in a white paper rather than just vague governance. Follow up and find some links on our best practices. We have very extensive online resources. I think Architecture Center could be a really good resource that has specific playbooks and kind of goes through the value of how you want to set up, using different topologies and stuff like that. So we can definitely provide a link for that. I'll send it to Kenna to send out, including in the recap and the post on Customer Connect. And then we have one talking about what's the difference between a route table and a security group that are both attached to a VCN.
Okay, so yeah, a security group is essentially that's attached to VNICs within a given VCN. So VNICs are typically attached to compute nodes instances, and these are similar to security lists, but they're directly attached to the VNIC itself. Whereas a route table is going to be what's going to decide where the traffic will be routed towards. So for example, if I had a network security group that did not permit outbound, let's say TCP/22 to some given node, then I would be denied by the security group before I even take a look at the route table to see what my next hop is. And if it was allowed, then definitely the route table would come into play, and it would say, in order to get to node X, for example, you must egress out of the DRG or an IPsec VPN tunnel, or an internet gateway, for example. So one is for security, whereas the other one's used primarily for routing.
Yeah, definitely. So one is like kind of what the access, like where can this traffic go? And the other one is saying like, here's where it would go, right?
Yeah, exactly. Yes, Uma.
Okay. And then we also have one that was talking about, is there a way that they can prefer IPsec VPN for a small range of IPs over Fast Connect? Or is currently Fast Connect is preferred over IPsec?
Yeah, definitely. I think, a quick and easy way around this, Chandra, would be to advertise more specific routes over the IPsec tunnel, assuming we're using BGP here, and have less specific routes get advertised over the Fast Connect. And that would essentially force routing to make its decision and route back using the more specific routes over the VPN tunnel. There's other ways you can certainly manipulate it by route advertisements and possibly ASPath prepends and things like that. But I think a quick and simple way is to advertise more specific routes over the IPsec VPN. All right, so this is essentially the OCI console and what it looks like. And I've already pre-drilled into our networking and VCNs, or the virtual cloud networks, just to quickly show. In order to get here under the main OCI console, I would navigate to networking and virtual cloud networks, and we would end up here. Here, what we'll essentially do today is we're going to leverage the VCN Wizard. So I would just click on Start VCN Wizard, and I have the option to create a VCN with internet connectivity or add internet connectivity and site-to-site VPN to VCN. So we're going to select the top one for now, and let's start the VCN Wizard. Perfect. One of the first things we're going to go ahead and give is it a name. So we'll just call it Demo VCN. Of course, the compartment that I choose to deploy this in, the subnets and the VCN CIDR, for example. So for this demo, I'm just going to accept the defaults. But again, we can support as large as a /16 and as small as a /30. Right, we can see we have these informations pop-ups right next to each one of these fields that can give us more information. And again, I'm just going to accept the defaults for the public and the private subnets. These are all modifiable. So we'll just click next. And essentially, it's going to say, hey, Raf, this is exactly what you want to deploy. Some of the gateways that are going to be deployed as a part of the VCN Wizard. So the internet gateway, the NAT gateway, and the service gateway, the security lists, and some route tables will be. So if we were to take a look, it shows us what these security lists are going to be defined as. And of course, there's two route tables that are going to be added. There's always a default route table that gets added. And in this case, we're going to create, with this VCN Wizard, a private subnet route table as well. So once we click create, it's going to go through the processes. And you can see it's very quick. Perfect. It's almost there. And it's done. So that took, I think, under 10 seconds. That was pretty quick. So if we were to take it the VCN at this point, it sends us or drills us directly into the demo VCN we deployed. We can see both the public and the private subnet with their CIDR blocks were defined. This was the CIDR that we could use. And again, if we were to come into here, we could edit the CIDR block and we could modify it if we wanted to. Instead of /16, we could go /17, for example, and save changes. We could take a look at the route tables. Again, there's a default route table with every VCN, whether it's created manually or the VCN Wizard. this will always come with it. In our case, we also created an additional private subnet VCN route table. So within here, this is the one that's being leveraged by the public subnet. Essentially, it's just a quad 0 pointing towards the internet gateway, whereas the private route table essentially has the quad 0 pointing to the NAT gateway. And we also added a route rule for all of our Ashburn services in the Oracle Services Network, the OSN, to use the service gateway. And so what this does, of course, is allow connectivity to publicly routable addresses, because OSN, or the Oracle Services Network, do have public IPs, such as object storage. Instead of leveraging the internet, we're going to leverage the OCI backbone in this case. So let's see what else we've created here. So no dynamic routing gateway attachments as of yet. The security lists, essentially we had the default security list and we created a separate one for the private VCNs. We did go through this when it asked for the confirmation. So there are subtle differences in this case between the two security lists. And we're going to take a look at this as well in the network visualizer, which is a tool that we're going to go over. DHCP options are defined by default for the VCN itself. And of course, in order to leverage the NAT gateway and the service gateway within the route table, they would have first had to have been created. So essentially one NAT gateway and one service gateway over here. So this is, again, a VCN with the proper components to quickly deploy and start using OCI, right? Deployed in a matter of seconds here. Let's see here. Let's go to the visualizer. So again, Oracle console menu under networking, we have this tool, a very handy tool called Network Visualizer. So let's just give it a second until it loads the map. And once the map is loaded, essentially this is the demo VCN we just created. So it's highly zoomed in, but if I was to click on the VCN level itself, on the right-hand side, we could start seeing the resource summary, the CIDR block, for example. The state is available. Do we have an IPv6 CIDR block? Not defined. However, we do support IPv6 as well. The default route table associated with the VCN. And if we wanted to view additional resources, we could essentially click on the button and it'll tell us what subnets are deployed, if we have VLANs deployed or not, the CIDR ranges, whether the subnet is public or private. So this really good information here. If I was to click on any one of these gateways, again, we will see what they're primarily made up of, what services are being used, if they're associated to a route table or not. This is for transitive routing. In this case, the service gateway is not. Again, with the internet gateway and the NAT gateway, same type of information available. Now, if we were to click on the VCN again, we have this resource map. There's a routing map and a security map. So let's take a quick look at the VCN routing map and what this is going to display for us. Now, there's some really cool information in here. Excellent. Whoops. So let's see if we can zoom out. So this is the VCN itself. And once again, within the VCN, we have at the edges, essentially, the NAT gateway, service gateway, or the IGW. Notice when I click on each one of these, it's actually telling me which subnet has a route towards it. And specifically, let me see if I can zoom in here, what's defined as a route rule when connecting towards the target, in this case being the service gateway. So all of the IAD services in Oracle Network. Now, for example, this is from the private subnet. What if we were to click on the NAT gateway? The NAT gateway is again being used by the private subnet, but here we can see the route rule. It's a quad 0 essentially, right? So this is very, very handy if we wanted to have some sort of a visual of our VCN, the types of gateways, the subnets, and their routing capabilities, and their what they're actually using for a next hop as a target. In the case of the public subnet down here, if I was to click on, say, either the on the public subnet or the internet gateway, we could see that this also has a route rule, quad 0, going towards the IGW. Notice as I'm clicking on these VCNs, we also have a ton of information that's popping up over here. What route tables they're associated with, their CIDR blocks, the type of subnet they are. So if we were to click on the public one, so on and so forth. So very handy information to have out of, almost, click of a button to have this visual topology and details of information contained within here. So this is essentially the the route map. Now, what if we were to take a look at the security? So if I was to go back up, let's say to the top level in this map view, I just click on Ashburn. Just give it a second here, please. So we're back to the top level view. And if I was to click on the VCN again, we went to the VCN route mapping. This time we'll go to the security map. And notice I could have done that easily when I went to the map modes, but I just wanted to show everybody you could do this by clicking on the map modes, or you could, if you want to go back to the top level, you could click on the top level map and then start drilling down from the VCN level. So here in the security map mode, this is essentially showing us again the subnets and how they're linked to the various security lists within the VCN. If we were to view additional resource details, it will define for us what security lists we have from an ingress perspective, and of course, right from an egress perspective. Now, again, these are stateful rules, so they must be applied on both directions. By default, they're stateful rules. You do have the ability to make these stateless rules. However, please keep in mind that if we did stateless rules, yeah, we do have to define them on both sides. In this case, it's not stateless, so it's not necessarily, if traffic comes in, since this is an ingress security rule, if traffic was to come in from this source, TCP, any destination, any source, but specifically for SSH, we necessarily would not need an egress rule for this. The only time we would need the egress rule is if we're initiating traffic from that subnet going outbound. And of course, the return traffic by default will be accepted because it is stateful by nature. Now, if these were stateless, if this was yes, yes, then I would have to define rules on both sides, for example. So again, we can click on any one of these subnets and we could take a look at the details and we could see exactly what rules are applied. So very, very handy instead of hopping around, let's say the VCN, for example. If I was to go back to the VCN, specifically the demo VCN, and I click on the subnet here, we could see the security list is defined here, the route table is here. And if I was to click on it, of course, I'm going to lose the view and I'd have to go back and go to the route table, for example, to look at the route table view. So it's all within a single pane of glass, just a few clicks, and we have a wealth of information from OCI's VCNs using the network visualizer.
Thanks so much, Raffi, for that. So it looks like we have a few minutes left. We can try answering maybe a couple more questions before we wrap up. So there was one talking about, is there any case where one can choose VCN-based hub and spoke topology? I believe you may have already answered that question, Raffi. I think some examples that I have seen is the prod, non-prod use case as well. Like you can also have your compartment set up between dev, test, and prod. But sometimes I also have seen customers, if they're connecting to on-premise application and they're trying to, let's say, automate a certain part of that application or something, they may have like a prod VCN as the one that has the DRG attachment to on-premise, and then maybe have a few non-prod as your spoke. So like your hub VCN would be that, and your spokes would be, your non-prod. I'm not sure, Raffi, if you have anything else to add or have seen any other kind of examples of when to use this.
Yeah, Uma, you bring up great examples. Essentially, if you want a centralized point of ingress and egress, then certainly a hub and spoke topology. A lot of customers like to leverage next generation firewalls, for example, and they want their traffic inspected. And they could have, multiple spokes, whether it's a single spoke, two spokes, or 20, 30 spokes. They want all that traffic to be inspected through a central ingress and egress point of view, for example. So that's ultimately a very good case to use hub and spoke topology.
Yeah, great. And then we have another question asking for examples of a software VPN.
Software VPN, we have there are a few out there. One that we have proper documentation on within our Oracle documentation is LibreSwan, for example. So it is a Linux-based system. It's a software VPN where you could actually use it free of charge. Of course, you could download the images and things like that and establish IPsec connectivity towards OCI or VPN connectivity. So hopefully that answers that question.
Yeah, definitely. And then another one popped in about third-party firewall vendors like Checkpoint, Palo Alto have OCI standard rules. Do we have any best practices for that? Is that something I'm guessing, in our documentation, or again, our architecture center is a great tool, may have some, answers for that as well.
Yeah, so we do have like many different third-party firewall vendors, and a lot of these are listed within our OCI marketplace. So if you're able to find it, there, like for example, we do have our Palo Alto network, like next generation firewall on our OCI marketplace. So within that marketplace listing is where you're going to find all the best practices related to that specific service.
Yeah, awesome. Thanks, Brennan, for answering that. There was also a question on egress data pricing for VPN Connect. Is there a place that we can look for that, or where people can kind of see that? Do you guys know?
Uma, I'll take a crack at that. So essentially, since VPN Connect is leveraging the internet, the egress prices would fall under the pricing model where the first 10 terabytes per month are free. And then it's a very, very minimal charge after that. So negligible almost. So yes, there would be pricing if we exceed the 10 terabytes outbound per month. However, it's really important to note that VPN as a service is free, right? So we don't charge for the actual IPsec tunnel and the connecting. So
yes. Yes, that's good to know. And then the last one, I'm not too sure what this means. Maybe you guys do, what the last mile issue is and how that's solved. If you guys don't know, we can also, come back to it, or I believe our information should be up on the site. So if there's any like specific questions, people who attended this can also reach out to us, but just wanted to address that one.
Yeah, I'll take a crack at that. So Deepak, I'm from my understanding, so the last mile issue is typically going to be resolved. Let's say if you're not co-located within an OCI data center. If you are co-located in an OCI data center, we have the ability to do a cross-connect natively between OCI and yourself, for example, or you could choose a third party or a partner to do the cross-connect. Now, if you don't happen to be located in the data center, then essentially you could leverage one of our many Fast Connect partners and work with them to get the last mile issue resolved. So essentially, from the customer data center towards OCI, typically would be through a partner or maybe a third-party provider. In either case, they're both supported. And then it would be from the partner to us, the connectivity. We already have agreements in place. We already have the connectivity models. So that wouldn't be an issue from our last mile perspective. But yeah, typically you would work with your partner or the third party provider to address any kind of last mile issues.
Okay, great. Thanks so much, Raffi, for answering that. So I think, we can start wrapping up now, just kind of going through the summary of what we went through today, as well as a list of links that we have here talking about our hands-on labs, different training and certifications. And then I think Kenna just threw up a poll, just asking you guys on, how helpful you guys found this webinar and session. And I will hand it back to her to wrap things up for us.
Awesome. Thank you so much, everybody, for joining us today. I saw some great questions coming through and folks mentioning that this was really helpful for certifications and just like general networking knowledge. So thank you to Uma and Brandon as usual, and big thanks to Raffi for joining us as our special guest and expert in networking to dive into this. As Uma mentioned, we have this final poll up. We always like to get a little feedback from folks on the session. And then we will be sharing out all of these resources, which I posted in chat and will also be on the replay. So you can do a little more deep dive into some of the hands-on labs labs or some of the training and certification and places like that were mentioned to get a little more information. And then as Uma mentioned, I think reaching out to them if you have any further questions and you dive into this and you want to know a little bit more, or if you've got maybe a specific use case, anything like that, do feel free to reach out and ask those questions. I always want to know what people are curious about or what challenges you're finding so we can help solve those. So thanks so much again to Uma and Brandon and Raffi for your presentation. Thank you to everybody for joining us in the audience and asking great questions. And we will see you on Thursday morning if you want to join us, or in 2 weeks for the next one of this series to wrap up the fundamentals this time around. So thanks everybody and have a great rest of your day.